In this video, you're going to see me solve some problems from mixed exercise 6D. It's going to be a pretty unpolished video. You're going to see me pause a lot because I won't be quite sure what to do. You're going to see me cross out. You're going to see me cut various strategies loose if they're not working and try alternative strategies. And I want you to pause the video often and do for yourself what I announce that I'm going to do. That will make it more interactive and enable you to learn more. Now, I can already tell from the fact that this is chapter 6 to do with radian measure that I'm going to be using a number of classic strategies. The first is naming, stating and equating. That is, I'm going to give names to things, like if there's a length I might call it x, if there's a radius I might call it r, if there's an angle I might call it theta, and I'm going to be stating facts using an equal sign. So if a rectangle was equal in area to a circle, I might write the formula for the area of the rectangle, I might write the formula for the area of the circle, and I might stick an equal sign in between them. So that's what I mean by stating and equating. More accurately should be stating through equating. In other words, you're stating facts, such as this is equal to that, and you're doing it by means of an equal sign. That's why it's called equating. I'm going to use Dear Mr. Examiner. I'm going to use that a lot. I'm just going to work things out even if I'm not directly asked for them, hoping that I'll get part marks for doing that. I'm going to draw a diagram, and I'm going to be doing a lot of mucking around. I'll probably be using other strategies as well, but they're going to be the main ones. Now, this will be a long sequence of videos because I'm going to try and do all 14 exercises from all 14 questions from mixed exercise 6D, starting with question 1. Okay, so triangle ABC is such that AB equals 5 centimeters. Now when I'm drawing diagrams, I often try to do it phrase by phrase. So the moment I see that AB is 5 centimeters, I immediately draw an AB. And then I move on to another phrase. Now as I add more and more phrases onto the diagram, it could be that a phrase that I add on early no longer works. That's fine, you just cross the diagram and start again. So what's my next phrase? AC equals 10. I'll make that roughly twice as long, but I'm not going to get precious about the scale. I've got no idea whether that's a good angle because I haven't read the rest of the question. And what's my next phrase? Angle ABC has to be 90. So that angle there, A to B to C, has to be 90. That's not very realistic, so let's do this question again. That's the 5, that's the 10. So A to B is 5, B to C, oh no, sorry, B to C is blank, and A to C is 10, and that's the right angle. So I've now got that on the diagram, that on the diagram, and that on the diagram. And now an arc of a circle center A and radius 5. Okay, so there's going to be a circle of center A, so it could be this, but they wanted to have radius 5, so here it is. Okay, so there's my circle. What else do I need to do? It cuts AC at D. Okay, so this is now called D. Now, one thing I'm a big fan of in terms of diagrams is not having lengths that cross over intersections. So the fact that this is a 10 is pretty confusing. Now one way of doing it is to draw great big arrows indicating the reach of the 10. But what I prefer, and again this is an example of being willing to improve your diagrams. So here is the 5. Now because I've got good squares here, there's no real excuse for not doing it nice and big and to scale. It's still just a sketch. I'm not being overly precious. I'm not even using a ruler. Some people might criticize me for that. So that was A, that was B, that was C. Okay, so that was all 10, but this was 5, and therefore that's also 5. So in my view, that's a neater diagram. And we got told that this circle intersected AC at D. Okay. Now, so just a couple of things. The area of circle, this is just me getting in the groove or doing Dear Mr. Examiner. Area of the circle is pi 5 squared. Area triangle ABC is half the base times the height. I could regard that as the base and that as the height. I know that the base is 10, but I don't know the height. I could regard that as the base and that as the height. Now I don't know the height, but I could work that out pretty easily. So here's some naming, stating, and equating. I'm going to